Hello students, we are solving the IB Math AAHL past paper questions and currently we are solving the IB Math AAHL May 2022 paper 2 time zone 2 past paper. Today we will be solving the question number 11 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring classes. So without any further delay, let us start answering question number 11. The maximum mark is 20. Two airplanes A and B have position vectors with respect to an origin O given respectively by the position vector of airplane A. RA is equal to 19, negative 1 and 1. This is the position vector of the plane at time t equal to 0 at the starting moment. Plus t, where t represents the time in minutes and t is greater than or equal to 0 and t is less than or equal to 2 over 2.5. So the RA, the position vector of airplane is 19, negative 1 and 1 and plus t, negative 6, 2 and 4. This is the velocity vector because this RA is the displacement vector. It is giving us the position of the airplane A with respect to the starting position. Where is the airplane A located after t minutes have passed? And we know that the distance traveled will be the velocity times time. So this is the velocity vector. It is no doubt the direction vector and also it is the velocity vector. And RB, this is the position vector of the airplane B, is equal to 1, 0, 12 plus T, 4, T times 4, 2 and negative 2. Okay. And they are saying that entries in each column vector give the displacement east of O, the displacement north of O, and the displacement above the sea level, all measured in kilometers. Okay. First one is east of O. So if I draw the axis maybe like this. So this is the x-axis. This is the y-axis. And this is the z-axis. Okay. So this is east. This side is west. This side is north because they are saying the first one is the displacement east of O. O is this region. Second one is displacement north of O. So this one is towards the north. This is towards the south. And the final one is the distance above the sea level. It is giving us the altitude. Okay. So this is above the sea level and this is below the sea level. So now the first question, subpart A. Find the three-figure bearing on which the airplane B is traveling. It contains 2 marks. We have to get the three-figure bearing of the airplane B. Okay. So, what is the direction vector of this airplane B? It is 4, 2 and negative 2. We will not be taking this negative 2 because it is giving us the altitude, how high it is from the sea level or how low it is below whether it is above the sea level or below the sea level. It is giving the altitude. And the first one is giving us how far is it towards the east direction, and the second one is giving us how far it is along the north direction. So if I take this, maybe this is 1, 2, 3 and 4. Okay. This one is 4 paces towards, or 4 units towards the easterly direction and 2 units towards the north. So 1 and 2 maybe. Okay. So where is the position of the plane? Is I'm not considering the altitude. It is over here. Okay. So if I draw this, then then this is equal to 4 and this is equal to 2. Okay. And which one is the theta? Which one will be giving us the bearing? Which angle? It is always, the bearing is always measured from the north in the clockwise direction. So this will be the angle theta. Okay. This is the angle theta. And this is, of course, a 90 degree. Okay. So this one is a right angle triangle. This is the angle theta. This is the 90-degree angle. And we have to find the value of theta. And we have to find the value of theta in degrees because the bearing is always given in degrees. This is very important. Usually you get the angle measurements in radians. So you are used to giving the angle measurements in radians. Your calculator may be set to the radian measure. But you have to be careful. You have to convert it to degrees because the bearing is always given in degrees. Okay. So we are seeing that the tan theta is equal to 4 over 2, which is equal to 2. Okay. So therefore, theta is equal to what? Theta equal to tan inverse of 2. Okay. So theta is equal to what? Let us see. Using the calculator, this is paper 2, we can use the calculator. Okay, so see, I have converted it to degrees. And fine. So tan inverse and 2. Okay, so it is 63, 3-figure bearing. Okay, so I cannot write 63.4. I have to write 0.63 because it is 0.4, it is not 0.5. So I have to take 63, not 64. So I have to give the answer as 0.63. First of all, let us write the answer for the theta as 63.4 degrees. That is fine. And they have said give the 3-figure bearing. Therefore, the 3-figure bearing is 0.63 degrees. Okay, it is 0.63 degrees. Coming to subpart B, show that airplane A travels at a greater speed than airplane B. It is containing 2 marks. We have already got the first 2 marks from the subpart A. And as I have said, these two are the velocity vectors. And how do we get the speed from the velocity vector? The magnitude of the velocity vector is the speed. So this is subpart B. So I am writing the speed. Okay, let me write speed of A is the magnitude of the velocity vector of A. So that is equal to -6 whole square plus 2 square plus 4 square, which is equal to 36 plus 4 plus 16, which is equal to 36 plus 4 is 40, 40 plus 16 is 56. Okay. And the speed of speed of B is 4 square plus 2 square plus -2 square, which is equal to 4 square is 16, 16 plus 2 square is 4, and -2 whole square is also 4. So 16 plus 4 is 20, 20 plus 4 is 24. Okay. So you are having your calculator, you can write um, the decimal equivalent of root 56, but we know that 7 square is 49. So 56 is more than 49, but it is less than 64, which is 8 square. So this will be something as 7 point something. This root 56 will be 7 point something. And what is root 24? 5 square is 25. So it should be less than 5. 4 square is 16. So this will be equal to 4 point something. In order to get the decimal part, we have to use the calculator. But even if you don't use the calculator, you know that because root 56 is greater than root 24, therefore, speed of A is greater than speed of B. Okay. So this can be our answer for the subpart B. And subpart C says, find the acute angle between the two airplanes' lines of flight. Give your answer in degrees. Okay, this also we have to give in degrees. They are not asking us to give in radians. So you have to remember this, that the answer should be given in degrees. And the direction vector of the two planes are -6, 2 and 4 and 4, 2 minus 2. So what do? We will be taking the dot product as we do, and we will be getting the angle. So I can start my answer over here. So this will be cos theta, and mind you, they have asked for the acute angle. Even if they don't write specifically that they are asking for the acute angle, unless they say that they are asking for the obtuse angle, just the word angle implies that they are interested in getting the acute angle. When two lines intersect, one angle will be the acute angle, another angle formed will be the supplementary, the linear pair, another will be the obtuse angle. In case you are getting confused, suppose these are the two lines intersecting. So this one is an obtuse angle and this one is an acute angle. Okay, so in case they are asking for the angle between the two directions, they imply they want to get or they expect the answer to be an acute angle. Okay, and the we will be doing the dot product. And in case the dot product is a negative number, the what is the formula? Let me write the formula over here. It will be, say, cos theta equal to d1. I'm taking the direction vector, or dA. I can write dot d2 dB. Sorry, over the magnitude of this direction vector times the magnitude of this direction vector. So this is the formula. And since these are the two magnitudes, these will obviously be positive numbers. But this part can be a positive number or can be a negative number. But in case this part is a negative number, cos theta equal to some negative number, we know that cos theta is positive in the first quadrant, but cos theta is negative in the second quadrant. That means for obtuse angles, cos theta will be negative. So in case you keep it in this form and dA dot dB is a negative number, the theta value that you will be getting by doing the cos inverse will be an obtuse angle. So you don't keep it this way, you always take the absolute value. So that even though you get the negative number while doing the dot product, you turn it to a positive equivalent. Okay. So we will be taking this one. It is okay. Let me just write it over here because maybe I don't have much space below. You won't be able to see. So this is 4, 2 and negative 2. Okay. So negative 6 times 4 is negative 24. I'm putting the absolute value notation. Plus 2 times 2 is 4. Plus 4 times negative 2 is negative 8. Over, we have got these speeds of A to be equal to root 56 and speed of B to be equal to root 24. So I don't want to get the magnitudes of the planes A and B. Again, I am just copying. Okay. So this is the thing, and I can come over here. Coming over here. So it is cos theta is equal to, this is, see, it is a negative number. 24 plus 8 is 32. So it is, or I can do minus 24 plus 4 is minus 20. And minus 20 and minus 8 is minus 28. Since we have to take the absolute value, it will be positive 28. Okay. So 28 over root 56 times root 24, and this time I have to use the calculator. I don't have any other option with me. So cos inverse of 28 over root 56 times root 24. We go to the calculator. Okay, and it is cos inverse of 28 over. Okay. So it is 28, sorry, 28 over root 56 times root 20, 24. Okay. Fine. It is 40.2. I am taking up to three significant figures. It is 40.2 degrees. Okay. So this is roughly equal to 40.2 degrees. The two airplanes' lines of flight cross at point P. Subpart D has two further subparts. The subpart I's question is find the coordinates of the point P. Now, these two airplanes are, you see, this is the displacement vector of the airplane A, and this is the displacement vector of the airplane B. You see the starting positions are not the same, and also the velocity vectors are also not the same. So obviously, even if they cross a particular point, if both the planes cross the same point, it is obvious that they will not be crossing at the same time. This is the first thing that you have to understand, that the times will be different because they have not started from the same point and they are not traveling with the same velocity. So, therefore, they will not be reaching a particular point at the same time. Therefore, this t can be taken as t1 and this can be taken as t2. Okay, because the the coordinates of every point on the line of flight of RA can be written as say 19 minus 60 and minus 1 plus 2t and 1 plus 4t. So these will be 19 minus 61 minus 1 plus 2t1 and 1 plus 4t1. Every point on the line of flight of the airplane A will be having these three coordinates. These are the general coordinates of the line of flight of the plane A. Okay. Similarly, the coordinates of any point and every point on the line of flight of the plane B will be 1 plus 4t2 and 0 plus 2t2, which is 2t2, and 12 minus 2t2. Okay. And since they will be crossing, both of them will be crossing this point P, therefore these coordinates can be represented by the first set of coordinates and also can be represented by the second set of coordinates. Okay. And since the point is the same, therefore this x coordinate should be equal to this x coordinate. So we are having this equation as this is I, or this is I. I have started the I over here and I am coming from here to here. So since the point is the same, the x coordinates can be equated, the y coordinates can be equated, and the z coordinates can also be equated. Okay, but we really do not need the three equations because there are only two unknowns. So I can take the first two. I can equate the x and y coordinates. Okay, so 19 minus 61 should be equal to 1 plus 42. And negative 1 plus 2t1 should be equal to 2t2. Okay, let us write the third one as well. I will not be entering this in the calculator. 1 plus 4t1 is equal to 12 minus 2t2. Okay. And I cannot use t1 and t2 in the calculator. So let t1 equal to x and t2 equal to y. Okay, we have to get the values of x and y. And these two are simultaneous equations, simultaneous linear equations. So we will be solving these using the calculator. So I go to menu and algebra and solve system of linear equations, and the number of equations is 2x and y. Okay. And the first equation will be 19 minus 6x. So 19 minus 6 times x is equal to 1 plus 4y. Okay. 1 plus 4 times y. And the second equation is negative 1 plus 2x. So negative 1 plus 2 times x is equal to 2t2, means 2y. So 2 times y. Okay. Let us see what values do we get for x and y. 2 and 1.5. You see the time is between 0 and 2.5 seconds. So both the values are between that range. 0 and 2, not seconds but minutes, sorry. Time is in minutes. So we are having one value, that is the t1 is 2 minutes and the t2 is 1.5 minutes. Okay. So let us write t1 is equal to 2 minutes and t2 is equal to 1.5 minutes. Okay. And let us check. We are having the third equation. So let us substitute these values of t1 and t2 and let us see if the third equation is getting satisfied or not. So 4 times 2 is 8. 8 plus 1 is 9. 9 on the left side. And what is the right side's value? It is 1.5 is 3 over 2. So, or even if I take 1.5, 2 times 1.5 is 3 and 12 minus 3 is 9. So, the third equation is also getting satisfied with this value. So, we are confident that these two values that we have got are correct. Okay. And now we have to get the coordinates of the point P. We are not asked to get the values of T1 and T2. We have got the values of T1 and T2 just to get the coordinates of the point P. We can use the first set of coordinates or you can use the second set of coordinates. Since the first set of coordinates means T1 is a positive integer, so let us take the first set of coordinates. Okay, so the coordinates of point P will be 19 minus 6 times 2 and negative 1 plus 2 times 2 and 1 plus 4 times 2, or P 6 times 2 is 12. 19 minus 12, you can use the calculator. 19 minus 12 is 7 and 2 times 2 is 4. 4 minus 1 is 3 and 4 times 2 is 8. 8 plus 1 is 9. So these will be the coordinates for the point P. Okay. So this is the answer for the subpart I, and coming to subpart II. Okay. Determine the length of time between the first airplane arriving at P and the second airplane arriving at P. We had also we had seen that T1 and T2, of course, they are different. So the we are seeing that the plane A is arriving at point P after 2 minutes, and the plane B is arriving at the point P after 1.5 minutes. So the plane B is crossing the point P before the plane A. What is the difference in the time? One is 2 minutes and the other is 1.5 minutes. So the difference in time will be is equal to 2 minus 1.5, which is equal to 0.5 minutes, or equal to half minute is 30 seconds. You may write it as half minutes or 0.5 minutes, or you can give it in seconds. It will be 30 seconds. Okay. You see, we have got 7 marks. Okay. Let d of t represent the distance between airplane A and airplane B for t, that is the time which is in minutes. Between 0 minutes, t is greater than or equal to 0 minutes, but is less than or equal to 2.5 minutes. And the subpart E's question is find the minimum value of d of t. It is containing 5 marks. And the position vectors of this is the position vector of the plane A, and this is the position vector of the plane B at any moment of time. So in order to get the distance between the two airplanes, we have to take a specific moment with time equal to t minutes. Okay, we have to take this particular miss. In the previous subpart we had there it was crossing through a particular point and they reached that point at different moments, different times. But in this case, when the question says that what is the distance between these two airplanes, at that for this we have to take the same moment. That means the time for this will be the same for both of them. This is the difference that you have to understand. In the previous case where we were studying when are the two planes crossing the point P, they were crossing the same point at different moments, at different times. So we had taken T1 and T2. But over here, when we are interested in getting the distance between the two airplanes A and B, we will not be considering the distance at time, say 1 minute, and of plane A, and the distance of at the say the position of the airplane at time t equal to 1 minute, and the position of the airplane B at the time 2 minutes. We will be getting the distance for the position of the plane A at say 1 minute and the position of the plane B at 1 minute. So the time will be the same for both the cases, okay, for both the planes. Okay. So this is the first and foremost thing that you have to understand. Previously there were two times T1 and T2, but over here it will be the same time. Okay. So let us start. So at time t minutes, the coordinates of plane A will be 19 minus 60 minus 1 plus 2t and 1 plus 4t. Okay. And at the same time, t minutes, the coordinates of plane B will be 1 plus 4t, 0 plus 2t is 2t, and 12 minus 2t. Okay. And now we have to get the distance between them. So we will be applying the distance formula, plain and simple. These are the coordinates of the point plane A. These are the coordinates of the plane B at time equal to t minutes. Okay. Therefore, d of t should be equal to, what is the distance formula? Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So we will be writing exactly the same thing. It is, I'm taking this one first. You can take this as well. So 19 minus 60 minus 1 plus 40 whole square plus negative 1 plus 2t, and this is negative 2t whole square plus 1 plus 4t minus 12 minus 2t whole square. Okay. So this is equal to, this is 19 minus 1 is 18, and minus 60 minus 40 is minus 10t whole square, and these two will be getting cancelled, so minus 1 whole square is plus 1, and this one is 1 minus 12 is negative 11. Okay, what about t? 4t, and this is negative of negative 2t is 2t, so 4t plus 2t is 60 and negative 11 whole square. Okay, so this is the expression for d of t. And now it is a paper 2 question, so we can use the calculator. Okay, because we need the minimum value of d of t. So let us graph this expression. Okay, so it is the square root, and first one is 18 minus 10t whole square. So it is 18 minus, instead of 10t, I will be writing 10 times x whole square, and there was that plus in between, plus 1 in fact, and plus 60 minus 11 whole square. Okay, 6 times x minus 11 whole square. Sorry, whole square. Okay, enter. Nice. See, this is the minimum point. Analyze graph minimum. Okay, So 1 point, I'm taking up to 3 significant figures. It is 1.81 and 1.01. Okay, 1.81 and 1.01. So it is 1.81 and 1.01. Fine. And if I just graph it, because it is containing 5 marks, so let us graph. This should not be there because it is the time. Time cannot be negative. And this is the d of t. And this may be 1, this may be 1, this may be 2, and this may be 1, this may be 2. So it may be like this. Sorry, it is a straight line, not curve. It is somewhat of this shape. You've seen the graph, right? It is a V type of a thing. This and this point is having coordinates of 1.81 and 1.01. And we are interested in which one? 1.81 or 1.01? 1.81 is the time. 1.81 minutes, at 1.81 minutes, the distance between the two planes is minimum. But what is the distance? What is the minimum distance? That is 1.01 and the distance was in kilometers. So the position vectors were given in kilometers. So therefore, from the GDC graphs, the minimum distance, or the d of t minimum, is equal to 1.01 kilometers. Okay. So this is the answer. The minimum distance between the two planes is 1.01 kilometers. And when is the minimum distance? When is there the minimum distance between the two planes? It is at time t equal to 1.81 minutes, but it is not required. It is not asked for. So you have given this information in the graph, but you don't have to write it explicitly because they are asking or find the minimum distance of d of t, and they are not saying and when is it happening. If they had said that when is it happening, you would have said that it is happening at 1.81 minutes. Okay. So this completes the answering of question number 11, the second last question of this paper. So thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math EASL and HL level tutor. I tutor students from both inside India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And as you are seeing, I am solving the past paper IB Math EAHL past paper questions, and I am uploading these solutions in form of videos. In case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And please, in case you have not subscribed to now, please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. In case you are having any doubts, any confusion related to this question, please feel free to ask me in the comment area. I will be happy to answer. And we meet again very soon in our next session. We will be solving the last question of the same paper. That is the question number 12. Till then, bye.